that's it. I think for the first time in a while, I am live. Hello, and I'm going to start by having a big slurp of tea because this has been some time since we've done a CodeZone, and I'm not expecting sort of a massive audience to appear or anything. It's be quite nice, like going back to the basics. And the plan today and tonight, completely unannounced, this CodeZone, by the way, so I don't expect anybody to be here for a while. The plan today is to start looking at least at the sound PGEX for the one low coder pixel game engine. And Megarev has joined the audience. Hi, Megarev. Hello. And, well, it gets a bit of a hard knock, does the old sound PGEX, because immediately people say, oh, you don't use it anymore, it's deprecated, we must use something else. But the truth is, it actually works perfectly fine, there's no problem at all. So I'm going to play, it works just fine. No problems at all. I can press this button, I can press this button, we can get some different sounds out, and we can filter the sounds. It's just fine. Stop that playing for a second. Megarev's not visited the Twitch stream in years. Yes, well, I mean, it's been a long time. I think this is the first coding Twitch stream I've done this year. Particularly first proper CodeZone. We've done some hurdy-gurdy streams, but this is the first coding zone. And I think we'll probably see what happens when people start to join in. Yeah, I mean, the idea is, well, what's happened is my child has turned 1. It's been 1 whole year, and I had sort of an agreement with the rest of my family that once the first year is sorted out, there's a lot of sort of legislative things happen in the UK. Once they turn 1, I'm no longer eligible to a lot of time off, which meant I was filling that time off with all sorts of things like getting the house done and basically getting my life in order. So we're kind of back to normal. Do you have a question, Joyce? Still upload to YouTube? Yes, yes I do. Just not as frequently, although the plan now is to get back to about once a month-ish sort of thing. It'll never be as frequent as it used to be, not anymore. I just don't have that kind of time. But yes, I've got some YouTube videos in the works. On Discord the other night, I was having a sort of on Discord you get a bit more of a behind-the-scenes look, and I think there's certainly topics for at least another 20-something videos. So we've got, all the material is there. I just need to get around to filming it and presenting it in sort of the one low coder way. And of course, the other big question people will have is, well, what's happening to Space Thing? Well, Space Thing will be continuing too. I'm going to take it in a slightly different direction. I've had some thoughts about it, and I'm going to integrate some technology I've been working on whilst I've been off air, as it were. But as part of the, well, I had this Discord chat the other night. I bumped the microphone. I had this Discord chat the other night with quite a few members, and it became apparent what we needed to do as a community to sort of get things moving again. And one of the things I wanted to get working was sound in the Pixel game engine, at least sort out some of these major complaints that people have had. And they're not necessarily well-founded complaints. It's usually people go, oh, you don't use the sound PGEX, it just doesn't work. Well, it's not true. It does work. It works just fine. It works just fine on Windows and Linux. The problem is it's invariably followed up with the question, well, how do I play my favorite MP3 file? And it can't do that. It's not its purpose, and it never will be its purpose either. But as you can see, it plays samples. It's fine. It works. Just it does what it needs to do, and it's very performant too. It's what's the running up there? This currently is running about four and a bit thousand frames per second. It's fine. There's nothing wrong with it at all. I have a question. I remember you did a video about assembly language. Yes, a long time ago. Any plans to create new videos about assembly language? Well, not really. It's not as common as people would expect it to be today. I guess the spiritual successor to the assembly language video would be the NES series. I do have some plans later this year to look at how we can parse and build an assembler. So I think as a byproduct of that, we'll probably see a little bit more assembly language. Yeah, I think so. Right. Okay, what am I doing? Don't know what I'm doing. Right, so yes, what are we doing? Sound PGEX. So the reason I wanted to look at this is because it does have some bugs. It kind of got a little bit neglected and ignored, and somebody, Scriptic UK on the GitHub, did actually point out that there was a sort of duration bug, that if you used the sound PGEX for longer than a few minutes, you'd start to get some interesting sound artifacts. In fact, you get sort of harmonics appearing, and that's because we ran out of floating point precision. Well, that's one reason, and the other reason was that we were doing some of the maths in a non-favourable way to doing floating point accumulation of numbers. So we were actually we were increasing our chances of error. Well, sort of fingers and thumbs. I've not done this for a while. So I thought, rather than just sort of fixing up the PGEX, well, I'll talk you through the story behind it. So the sound PGEX exists, but a version of it was given to me a few months later by a member called Magetsup, popular member on the server, who created an X Audio backend. Now, my sound version used a Windows Multimedia sort of from 1965 or whenever that was created, and it did the job, but it wasn't very particularly quick. And Magetsup produced an X Audio backend, and I think X Audio now is ubiquitous enough that we could use it on as the default backend. But another chap came along called Slavka, and then created backends for Linux versions of the audio. It's all sort of it's all bits and pieces. It's all a bit of a mess, the whole thing. It works, but it's just all over the place. And that's because it's grown very organically. This started life as part of the console game engine. That's how far back it goes. It was a purely Windows technology. I just needed it to do some beeps and bloops as part of a demonstration about my synthesizer stuff. In fact, actually, it's before the console game engine, isn't it? It started life as Noisemaker. And it's just grown sort of organically with bolting more bits into it. And I think now's the time to sort of look at designing it a little bit better. Standard int, hello. Alex, hello. You're working with a Z80 CPU. I mean, are you working with it as a hobby? You're building your own computer, I suppose, yeah. I mean, I do use a little bit of assembly periodically when I'm working with... I work with PIC microcontrollers a fair bit at work. I tend to use... ARM as well. Now I use ARM M3 controllers. And if you've not seen a CodeZone before, well, they're not as slick as the YouTube videos. There's no editing. It's all live. It's all very much unplanned. And usually completely gets derailed by something that pops up in chat. And I have a new look as well. I have new graphics and things on my layout, which I'm quite pleased with. Right, so this is the existing sound PGEX, and there's lots of sort of interesting things to look at how this is structured. It's designed to work on cross-platform, so you've got all the usual sort of compiler stuff at the top. But there's a single interface called Sound, which made it very easy for the end user to actually use. So let's look at a user-facing application. So the application I've just been running, it was this one, and it's a standard Pixel Game Engine derived class with a non-user update and non-user create function. The Sound PGEX also gave you this ability to link in your own functions. So if you wanted to generate sound, it would provide you with this synth function, which you can you do what you want. In this case, I'm playing a sine wave based on what key I'm pressing, and there's an ability to modify the output before it got sent to the speakers. The point being is that the end user doesn't care about how the sound hardware is doing the job. And it provided some basic utilities. We could load WAV files, we could set those functions up, and that's all we need to do. We don't need to do anything else at all. We can call play sample whenever, it's just fine. But I want to retain the simplicity of this implementation, but I want to modernize the back end quite a bit because it's written in a style of C that I was writing, well, I guess 5 years ago. So I'm not really leaning on the standard library. There's a few bugs in here as well, and the way that we can implement these backends is just completely ad hoc. It uses these if defines all over the place. There's basically 3 functions you need to override. And we'll try and find an implementation. So here we go. So this is the X Audio implementation. Oh no, this is WinMM implementation. So the three functions that somebody would have to override is this initialize audio, which sets up the audio hardware, destroy audio to clean it all up, and audio thread. And I noticed that in audio thread, we've actually got the same code over and over again. We sort of do this little bit of mathematics to work out some numbers. I mean, none of this is necessary anymore. I mean, just look at this. It's all completely changed. It's also not very flexible either. It's everything's sort of built in fixed types. So I think we'll have a look at changing a few things. But this ability here to fill the audio blocks with data, it's just repeated. So we go down and now look at the X audio implementation, and it's exactly the same code. Exactly the same code. It's down here. And then we go and look at the ALSA implementation provided by Slavka, and it looks very Linuxy and C-like to start with. And then you get to the main loop, and it's exactly the same code. Well, almost exactly the same code. So I think there's scope to make the actual creation of audio backends and audio interfaces to be a little bit more programmer friendly, and that way we might actually get a few more audio backends, because I'd quite like to get an SDL mixer one. Let's have a look. Kit Carson, hello. Saucy, hey, Saucy63, hello. Yeah, I don't think many people will be programming in Z80 these days. Seriously, I think it'll just be hobbyists and potentially some legacy. Mycon, hello, yes. Yeah, it has been a while. So I was just describing to people, there's a lot more people have joined the chat now, and I'm sorry if I'm repeating. Basically, my last year, obviously, I've been raising a child, and in the UK, you're entitled to a certain amount of leave as a result. So I was allowed, turns out I was allowed about 4 months paternity leave, which is, it's unpaid, so it's a voluntary thing. But it means I can take 4 months off work, broken up, without being fired or losing my job. So I took full advantage. I've actually worked since I was 16, so it was the first long period of time I've ever had off. And whereas you might think, with all this free time, I'll write loads of code and I'll do loads of one-lone coder stuff. Actually, I was sort of fixing my life. I had surgery and I got my house renovated and I'm sorting out a few things for my family, and just it was time to do all of those sort of things. But now I'm back at work. My family are healthy and good. I'm better than I've ever been before. I'm feeling good, and I thought it's time to sort of get one-lone coder kind of up and running again. It's been a bit on hiatus, but here we go. X10 and the family are just fine. Alta, hello, yes. No, we're all good. Like I said, we were celebrating a first birthday at the weekend, and it went very well. We had a bouncy castle, and only one person was sick in the bouncy castle, and it wasn't me. Carrying on with the theme here, we look at this as the OpenAL. I'm pointing at the screen, like you guys can actually see what I'm pointing at. But here's the OpenAL implementation, and again, it's got sort of all of its custom code, but it's got the same code. Here we go, same thing sort of built in. And one of the errors that was pointed out by Scriptic UK, I'm not taking any claim on this, was that we were accumulating global time. Now, global time is important in the sound PGEX, because if we go to the user implementation and look at the custom makesynth function, so this just plays a sine wave. Of course, we do need to keep track of time in order to call the sine function on that variable, and we can generate the waveform. Well, keeping track of a floating point number over time is actually quite tricky, particularly when you've got a way of sort of amplifying that error in an annoying way. You can hear the errors creep in. Now, I'm not going to do that via Twitch and set up all of the streams and things. You just have to take my word for it, or go and have a look at the demonstration that's on the GitHub right now, because I've not uploaded any of this stuff, which was based on standard single precision 32-bit floats. The easy hack is to immediately just turn everything into double. That's good and bad. But there was a difference as well. There was another point that Scriptic UK introduced, and I think it's worth looking at, was here in this main loop. I know there's a lot going to go over people's heads here, and I do apologise, but the idea, how it works, is you basically just have an array of 1,000 samples, and you've got to repeatedly call a process to fill those samples because the sound card is demanding them. So you don't want the sound card to be starved. So every X milliseconds the sound card goes, yo, give me some more data please, and gives you a block to go and fill up. And that's exactly what we're doing. But as part of that, as I was iterating through the block, I was increasing global time. Well, by the time step, that's one sample's worth of time, every single time we went through this loop. Now, I don't care about the performance impact of that, but of course we were accumulating this floating point every single time, and there's always a floating point error. So, floating point numbers is A plus B, plus or minus some error. And you want to try and minimize that error as much as possible. So I actually did that according to, again, Scriptic UK's guidance in how to implement this in the back end. And he says you take the code out of the loop. So here is the main loop again. And instead of doing that, you just do it as a one hit, as a multiplication, the total number of blocks, number of samples in that block, and that's how you increment the time. So we've really just got now sort of 2 sources of error rather than 1,000 sources of error. So it's a very good use, very good observation by Scriptic UK, and I've implemented it. And indeed, I cannot now detect any sort of meaningful error within the first 10 minutes or so of the application running. He claims, or he or she claims, that about 5 minutes in you start to pick up on a harmonic, but I'm not so sure. Thews, hello. Good to see you, Thews. I hope you're well. That's how getting time off works when you're an adult. Yes. It was filled full of family things. Now, what is the motivation for getting the sound PGEX up and running? Well, I've got a few videos coming up where I want to talk about waveforms and sort of the viewing of waveforms and how to manipulate them graphically in a sensible and reasonably efficient way. And on the whole, I feel like I want to revisit the synthesizer series too. It's how the channel started, and there's still more stuff to talk about when it comes to audio synthesis and effects. But I wanted a reliable platform that people don't just immediately go, oh, that's the Pixel Game Engine sound implement, oh, stay away, avoid like the plague. It's not that bad. So I thought it's time to sort of reinvigorate this file, which I mentioned before, is this organic blob of code which has sort of mutated over time and had all sorts of people chipping into it. I think it's now time to turn it into something that's a bit more engineered, and really that's what I wanted to do tonight. So if you're not familiar with CodeZone streams, they are sort of the how do the OLC YouTube videos kind of get made in a way. That's one side of it. The other side of it is we have this space thing going on. And it can be full of bugs, it can be quite embarrassing for me, and it can be quite slow. And we tend to only do like an hour-long stream as well, so we'll see. Dragon Eye, hello, good. Yeah, good to see people turning up. That's good stuff. So, where do we start? Well, I think we'll start just by defining the interfaces that we want, and if we get time tonight, try and cut and paste as much of this as we can and re-engineer it into just doing the Windows Windows Multimedia implementation to begin with. Because once we know that one works, it's the easiest one to implement, the easiest one to test, then we can start sort of engineering in the other audio backends. And the purpose of this exercise is really, 1, to keep it simple for the end user, but 2, to keep it simple for other people to create audio backends. I'm really keen for somebody to come along and create an SDL mixer backend, because that way we can quite happily use the sound PGEX in the scripts and builds. We can use it in the web browser, which I think is an important goal. Dragon Eye needs to get some popcorn. Well, we'll see. I've not done any live coding for quite some time, so I'll just run this application. So this is the sound PGEX that isn't quite on the GitHub, but it is with Scriptic UK's implementations of changes, and I think it's now working just fine. You should be able to hear that. And I've added a little visualization to this demonstration. And you have those two functions. One was the set user synth function, which is what we're doing here. So that's the sine wave being created. Oh, that's quite a nice one. There's just like an arbitrary trigger point. So if you know anything about oscilloscopes, it should be somewhat synchronized. It doesn't do that. It just plays whatever it can see in a data block at the time. So that's why it doesn't have any sort of horizontal hold going on. Now, there's also my user filter function, which is what I'm using for the volume, so I can control the volume up and down. Now, you might be picking up on a bit of noise there. You hear that? That's an effect we talked about in the NES series, that just by... If you just change values in these audio buffers, you're always going to introduce sort of these very high frequency distortions. So if you have like a step change, so in audio you kind of want everything to be smooth and sine wavy like, but as you change the volume, at some point in this buffer there's a step change, and that's not really something that can happen in... I'm going to sneeze here. I can feel it coming. Oh dear me. There's always two. There'll be another one in about 30 seconds. Thank you for all of the blessings in the chat. Could the STLV implementation be the relay race? So I shall plug the relay race momentarily. It's not been that sort of... not many people have applied to take part. Not last year, a couple of years ago, we did a relay race. It's a really fun and frustrating event. We had about 10 people take part into two teams, and 2 teams of 5, and they had a goal to implement. In this case, it was implement the first level of Super Mario Brothers in reverse. And they had 40 minutes per competitor to write some code before they have to move on to the next person. And it was good. We had live streams of all the code that was going on, and there was commentary, and there was interviews with the developers. So we set it up like a sporting event, and I think it was a lot of fun. People, the chat afterwards in Discord was going insane. Thank you, Dolphy Ulfgurlgert. Thank you, Dolphy. I'm just going to say Dolphy. And so it was great fun, and we thought about doing it again, and it turns out that this Saturday, the 25th, was when we were going to do it, if there's enough people interested in doing it. You don't know what the event is, what the task is going to be, but if you're interested, get on the Discord. There's some posts about how to take part and join in. So I'll plug that again towards the end. Right. What was I going to do next? Oh, there's also... Yes, I played some samples, didn't I? That's what I was going to get OneNote up and running. One moment. OneNote going, because I don't recall where we're up to with slides. Okay. And check this out. Whilst we're doing synth stuff, look at this. This bad boy's come back out, and we might get something going with this in a video later this year. I think that's really the goal here. Right, I've got my trusty tablet pen. You can hear it go pop. Right, okay, so let's have a quick listen for that. So we press a key. There's a distinct click. Well, a click in audio it's actually just a high frequency sound, a brief high frequency sound. And the problem you've got is you've got your speaker cones. That they need to move backwards and forwards to play the audio waveform. So as the audio waveform is nice and smooth, the speaker cone is doing the same things, except backwards and forwards. The problem is, when we're generating this audio data, what we're actually generating is something rather artificial. So we have like a flat line like this, and then we introduce some sort of sine wave. So here we've got an almost vertical transition from rest to active sine wave in one single sample. Now that can't happen, of course, by my hardware here. My hardware cannot go from existing in this location to this location instantaneously. That would defy the laws of physics. It does the best it can. It gets there as fast as it can. But this rapid change in signal is actually a high frequency, and this is borne out through the generation of square waves using sines, right? So if you've got lots of sines of sort of different frequencies like this, and higher frequencies, and if you add them all together, you end up with square waves. And some people actually quite like the sound of that distortion. I do too. It's very retro. It's one of those nice things. So, I mean, why it doesn't actually look, it's not a perfect square wave, these things. They tend to look a bit like this. There we go. I've got something going ping. Oh, there we are. So YouTube subscriptions for some reason. And the more sine waves you add in, the squarer the wave gets. And if we ever get around to looking at the fast Fourier transform, that'll all start to make some sense. But there's plenty of resources on fast Fourier transform. You don't need me to bore you about complex numbers. But anyway, that's why you're hearing a pop when you start and stop the sine wave. And to get rid of those pops, you need to filter the waveform. And in my synthesizer series, I did actually look at putting in some was it the attack, the sustain, the release, and the decay, or maybe not that way round. But they have like a filtering envelope to apply that and stop that from happening. And you may even have some like deliberately built-in high frequency filters anyway, just to stop that from happening between programming errors. And it could well be that the drivers have that feature too. They're just not sharp enough. Anyway, that's why you can hear a pop between the notes being played. Just going from rest to some point and immediately in a sine wave. So why does the square wave pop constantly? It does, but that's what gives it its sound. That's in fact what you're relying on. The square wave is high enough frequency that it gives you that lovely warmth. Well, we can play with it, right? So if we go, let's turn this into a square. I told you this is what happens, right? We're going to, tonight was about refactoring the sound PGEX, but now it's become this. So instead of taking the sine wave, if I threshold the sine wave crudely, for now, this is going to be between -1 and +1. So if I say it's greater than 0, then return. What are we doing here? Greater than 0. Return 1.0f else -1.0f. That's pretty extreme. So this is a square wave being generated just by that sine wave being thresholded, I think. We'll try. Hey, we get some. This could sound really terrible. It could be also like nasty in your headphones. So it's firstly, it's much louder, and that's because there's far more power going into this this waveform. But that sort of retro kind of is this the X audio backend? I think so. Nice. That sounds awful. I think some people think it sounds awful. I quite like it. To me, it's like if you remember the BBC Micro, whenever you switched it on, it used to go before it was ready to use. I don't know why, if that was a programmed-in thing or not, but nonetheless, it was that heartwarming sound. Yes, let's go. We're ready to play games. We're ready to code. Oh yeah, it is a bit harsh. Old school vibes, exactly, right? And that's because it was very easy to generate square waves to generate audio. Again, something that we looked at in quite a bit of detail in the NES audio generator. So that harshness that you've picked up on there, that harshness that you've picked up on there is exactly exploiting that wave, the nature of the square wave. Can make it really annoying if we double the frequencies and make the really high-pitched noises instead. That'll really annoy everybody, won't it? Let's do that. So I've doubled the frequency now, so in theory we've gone up an octave. Yeah. Dragon Eye bot is doing its thing. Well done. Should we go up again? Let's go up again in frequency. Let's go really high frequency. Let's start to see where does it all fall apart. Is it a saw wave or a square wave? This is a saw wave in this instance. Sorry, this is a square wave in this instance. Now, you can start to hear, maybe you can't, I don't know where the compression starts to take effect and start doing its own filtering. When I play these higher notes, you can distinctly hear there are... You can distinctly hear there are other frequencies being played. It's not clipping, but there are other things going on in there. There's high and low frequencies. The higher pitch, more louder, it seems, due to the psychoacoustics. Well, I mean, yes, I suppose that's true. I mean, if we go like really low frequency, if we go the other way, so it was set to 2. If we set this to 0.125, now we could get to the point where you can't actually hear this. Let's see what this is like. Yeah, that's some fat bass. I like that. Is that knackering everybody's speakers and headphones? Good, good. Turn the volume down a bit. Ooh, that's nice. I think that's a bit too low if we want it to be bassy. So let's plug that as 0.5. I'll just try around there. Gonna have to do more than this to mess with. I'll turn that volume down to begin with. So. I think there's a glitch in my keyboard handling code that allows me to sort of up. That's not an intended way of playing the thing, but it just seems to work very nicely. Get some beats on that. There's that one. Oh, the sample's too low. The volume affects the whole thing. Flight of the Bumblebee. Yeah, I'll just learn that one real quick. Yeah, low pitch. Well, I'm a fan of triangle wave for bass, and I can't remember the formula for implementing a triangle wave just off the back of my head here. I can't remember. I usually create my triangle waves by adding, is it slightly out of phase sine waves? I can't remember. It's been so long since we've done any sort of sound synthesis. Anyway, there we go. We've got the. I can't remember what we were doing now. Oh, look at this. We get up on hand immediately with calculation for triangle waves. So let's bang that in. And I guess the frequency we're after is all of that is X. Do you have the fract function? No, I was just going to fmod with 1. Yeah. Fmod, all of that. So this is on Magetub, so we're going to see if this is any good. Which bracket am I? That one. This might not work, but we'll see. We shall see, Magetub. We shall see. We'll keep it just all. I can't even remember what types it's going to be. Fmod. Oh, because it's you're getting everything sort of all mixed up. We'll just have to, for now, sort of stick in floating point. Standard min is falling over. Standard min. So I missed a bracket off. Standard minimum of u. No, that times 2 is out of the standard min. Double. This is one of the things I no longer like about the modern C compilers. Is that they're just not forgiving anymore on casting. You kind of think that it used to be all right, but now it's hard work. What are we falling over here? So this is saying argument types are double. Is that because this? Because it's timing by d global time. That's taking control. And we'll need to cast this bit. And double. Don't work, Magetsu. Don't work. Parents after the second deglobal line. Am I really missing a parenthesis? That one's there. That one's the standard min. Oh, it's the yeah. Okay, no, I get you. Gotcha. Good spotting. And we'll bang that there. Right. Okay. So according to Magetsu, the synth legend on the Discord server, this is going to be a beautifully fat, wonderfully sounding triangle wave. Here we go. It's a triangle wave. It's a much higher frequency one than I was expecting. Much higher frequency than I was expecting. I guess it doesn't make any sense anymore, the frequency timesing it by all of this. Let's reduce it. Oh, that's really too low. You can see it bouncing up and down. Now the interesting thing is my speakers will actually be doing that. So you have to be careful with doing this sort of thing. Oh yeah. Yeah, triangle waves always make better bass. Might just take the edge off that just a bit more. Let's change U2. These are rather arbitrary, these numbers. We're just mucking around with getting good sounds now, aren't we? Yeah, no, I quite like it. Anyway, I talk about all this sort of stuff in my Code It Yourself Synthesizer series, and so we don't need to talk about it today. Right, good. Anyway, we've got different functions. Yes, you can do, surprisingly, you can synthesize different sounds. Imagine that. But the objective today was to start looking at refactoring the sound PGEX, and instead of just making the changes, I'm actually going to make some significant changes, which is basically going to be API breaking, which means I can't just call it the sound PGEX and be done with it with a load of new implementation. I need to create a new PGEX instead. So I'm going to call this one the sound wave PGEX, and we'll start making some of these changes to the back end. I quite like the simple nature of how the PGEX works. The user really doesn't have to do very much. Now that's all the user-facing functions there. Get mixer output probably shouldn't even be publicly accessible, I don't think. Well, it's synths and waves. Yeah, we probably weren't getting a very good, efficient waveform coming out of that function. Certainly looking at it then. So all the user did was load up the WAV file, and they can play the samples and stop the samples, and they have this function called get mixer output. So there's two parts of this. We looked already very briefly at sort of the back end, which is handling all of the hardware and the drivers, but the actual PGEX itself provides some basic mixing functionality. So if you've got lots of samples playing simultaneously, so if I go back to the demonstration, these are all samples that are overlapping each other, and we can audio. We're getting distortion there because it's clipping. Ebb and flow. Makes pop and beep. No, it's going to be called sound wave, because that way it's distinction, and it's also it makes makes clear a point that I raised right at the start here, is because there's a lot of people here now. Oh, thank you, Standard Ed. There's particularly Dragoneye and Magetsuba here, and Magetsuba is a key contributor to this particular PGEX, so I'm pleased that he's here. There's this myth on the Discord server that if anybody says, how do I do sound in Pixel Game Engine? Oh, don't use the sound PGEX, it's broken. It isn't. It works, and it's worked for quite some time, and it does the job just fine. The problem is, invariably, the next question will be asked is, how do I play MP3 files? And it won't do that. That's a much more complicated set of problems to worry about. It's just for handling basic, simple waveforms. So I think by calling it sound wave, we sort of emphasize that's all it's for. Or we could call it synthwave, couldn't we? We're missing a trick here, just synthwave. Yeah, but then we're starting to bring in other stuff, though. If we could always bring in MP3 loading, and then somebody will go, oh, well, I want it to play OGG files, and then somebody will play, oh, I want it to play whatever proprietary Mac rubbish is popular. You see, I've no problem with just converting MP3s to WAVs. The trouble is, people then deploy their applications with WAVs, and of course they suddenly wonder why they're deploying a 500 meg application, even though everything just compiled to about 300 kilobytes. So I want to keep the the play sample and the stop sample and the stop all. That sort of simplicity is what I'm aiming for. But what I wanted to work on was the ability to implement better back ends for these things. Design our own compressed audio format. That'll be popular. And what I'm trying to avoid, I'm zooming out here. You won't be able to see all of this on the Twitch stream. I'm trying to avoid this duplication of the same sort of ideas of code. It's so scattershot. It's all macro guarded, and I just think it's done in such a way that was right at the time, but now is sort of become difficult to maintain. That's the plan anyway. It gets a bit tricky with the Linux stuff because I don't currently have a Linux platform other than my Raspberry Pi to really sort of try these things out with. And that was the default. Yeah, it's quite interesting to see, actually. So if you did want to implement your own backend, you only had to provide those 3 different functions. And you sell it as if it really is that simple to do. You just provide those 3 different functions. But then you also need to provide all of the macro stuff at the top to make it play ball with the operating system and make it play ball with compilers. And actually, Magetsuba, that's a good point. Whilst I'm here, I actually ran into a few problems with your X Audio setup. So originally you do this sort of check for Win32, WinNNT, and I don't quite understand what that was doing, and it didn't work. So for some reason it stopped working, so I put the original code back in. I think that was it. Yeah, it never comes true because Pixel Game Engine itself actually defines this. And I can't for the life of me remember why we define it. So if I go to Pixel Game Engine, it's something to do with code blocks. That we sort of describe it as being Windows 2000. And the reason I can't remember why is I can't remember what that meant. But because code blocks and MinGW are just awful, They needed this in order to compile Windows properly. So there's something that needs addressing there, and that's why I'm sort of making it so the audio backends are a little bit more self-contained, encapsulated. The audio thread function is definitely not simple. No, it isn't. No. Okay, I agree. It could be a lot worse. It's not. It's not the most complicated function in the world. So if we go and have a look at the WinMM audio thread one, let's just have a look, see what it's doing. It'd be good for me anyway to try and get back into what it is doing. Just got to find where it is. So, yeah. Initialize audio. Right, the audio thread. So this is a separate thread which is then running the audio in the background. And you see, there's all sorts of things in here which is just garbage, and we just need to change. So the thread starts at this point, so global time becomes 0. Depending on the sample rate that the hardware is configured, we do want to sort of keep track of how much time is passing per sample. Then, whilst the thread is active, we sit in a loop, waiting to be signaled by the operating system that we have one of these blocks of memory free. And if we've not got a block of memory free, we just sit and wait. We don't do anything at all. We sort of pre-allocate a number of blocks in advance, and the number of blocks that you allocate is what adds up to latency. So a block could contain something like 256 or 512 samples, and it will ask you for these blocks, and you populate them. And if you don't care about latency so much, you can populate quite a few in advance, and then just leave the operating system to basically drain them all as audio coming out of your speakers. Now, in Windows and on the Windows MM implementation, once you get a block, you just sort of prepare its header, you give it some instruction to say, I've got some new data, come and play me, and then you copy the data from your calculations into that block, update your time, and then write out the block again. And that's the end of the thread. So, I mean, the thread isn't that complicated. It's not very big. That's it. A bit more than that. That's the whole thing. But yes, it is actually doing a lot. There's a lot going on that the operating system is doing for you. All of the setup and initialization is done in this initialize audio function. And WinMM is nice and simple, and that's why I like it. And if you go and compare that to something like the more Linuxy ones, the ones I just don't understand at all. Look down here. Just the really, obviously there's one here that's just full of like C code. There we go. The ALSA. I don't like this. I don't like these sort of really repetitive function names. I know it's quite a popular coding style, but it's not for me. So I guess they're doing the same things that WinMM is doing. They just look a bit different. But the audio thread is pretty much the same. Other than, I guess it checks for blocks in a slightly different way, whereas I was using condition variables and to signal this change. I guess that's not quite how it works on the Linux environment. Don't know. I don't know how ALSA works. I've never programmed with it. This is a Slavka's code, and I was very grateful that it worked at all. Right. So we're going to start with basically creating and defining the interface. Now, how am I going to do this? I am going to be cutting and pasting from this file because I don't want to have to rewrite all the code from scratch. But I do sort of want to write it in a slightly more modern way and slightly more maybe user-friendly way now. Yeah, we're going to have to worry about loading audio samples as well. Maybe we need like an audio loader function, which can be overridden. So if somebody does want to create an MP3 extension or something like that, they can do that and the two can play together. That might not be a bad idea to do at all. We do something similar in Pixel Game Engine for loading images. You don't have to use the built-in tools. You can use STB image if you prefer. Another YouTube subscription. I definitely need to learn how to turn those off. I do like the idea of the two customizable functions. That's not going to go away. That's fundamentally how the synthesis works. But I was thinking, should I combine it with Controversial opinion, we'll get the opinion of the chat. So this is a video that's coming up. I mentioned it on the Discord server the other night, where I'm going to talk about waveforms. And you can see it's all starting to form a bit of a common theme. Because I thought if I'm going to do a set of audio videos, then I want a way to actually view audio data in an interactive way. And so I created a basic continuous buffer is probably the way to describe it. So let's have a, how did this work? Let's try and remember. So it was a waveform view. It didn't actually store any data in here. The data is whatever it needs to be. It's just an array, a big lump of numbers. And there could be multiple channels of data in that. We'll see the waveform view can sort of extract stereo or 5.1 or whatever. It doesn't matter. But the idea is it did the interpolation between samples sort of automatically. So you could just sample and grab immediately the value, basically cast the time to an integer and grab that sample. But in reality, if you're plotting these things, it can be quite useful to sort of interpolate between the samples. And I thought, well, is this sort of the buffer that we should be using in the new sound extension? I think it might be, because that would allow us to sort of easily manipulate time, basically get that for free, if all of your buffer indexing is also operating in the floating point domain. So you could then change the pitch of notes and the pitch of samples quite easily without needing to record multiple samples. So there's some merit to doing that. Don't know yet whether we want to do it, but the fact that I've got a class here that's ready to go that can handle multiple channel sort of data, it makes me think, well, we probably should be using it. I also created a wave file class which allows me to open up a WAV file. And unlike in the current sound extension where if the WAV file doesn't conform, this one can potentially actually go ahead and convert the WAV file into something it can play. So upcoming video about how to visualize waveforms is going to use these things. I thought, well, actually, maybe these things are good to include in the sort of sound wave PGEX. They're sort of all together. We might bring those in. I'm thinking of this live. I don't currently have a plan, so yeah, I think that might be the case. The nice thing about the waveform, it can be any data type at all, really. It can handle by using a stride and offset as part of the sampling calculations. So when you sample the pointer of the data, with stride and offset, you can sort of have the data configured in a variety of different ways. But nearly universally, you have channels interleaved, so you'll have left, then right, then left, then right, then left, then right. You don't sort of have a big chunk of lefts and then a big chunk of rights. Is MP3 format still copyrighted? I think it's copyrighted, but I think it's now it's not licensable anymore. Is my understanding of it? Yeah, I think the name of it and the tech behind it is still owned by somebody, but yeah, there we are. It's open for people to use. Yeah, okay. I think I will. Well, when we get round to worrying about audio samples, that's how I'm going to sort of store them behind the scenes. Might rename this somehow. Yeah. We've not got very far today, so let's bang in a new file. Add new item. Header file, and we'll call this then the OLC PGEX. Right, we get the choice now. So vote in the chat. Is it going to be the synth wave or the sound wave? It's going to begin with S. Literally anybody that types first will have this. There we go. Sound wave. That's what it's going to be. Sound wave dot H. 2 votes for sound wave. I agree. Synthwave would be an awesome plugin for something else, I imagine. Right, there we go. Sand wave. Sand wave. Or sandwich. Sandwich. Right, I can't even remember how to construct PGEXs. We'll copy all this blurb in later on. But we do need some basics to get us going, don't we? Yeah, so we have header guards going in. Additional header guards. And if. And we put the implementation down here, don't we? It's been a long time. It shows you how long I've been out of the game on this sort of thing. I can't remember how to do anything. Namespace with the thing in, so we'll put all of our headers up there. And then, yes, we've got our sound. I'm going to be changing the names of these as well. I will change those over. Right, so this is sound wave, sound wave, sound wave, and sound wave. So in a PGEX and basically the Pixel Game Engine, we're going to have our sort of declarations up here, and we'll have our implementation down here. Now, the distinct difference I want to do this time is I want to potentially look at keeping the development of this project as multiple files. We'll see if we get that far. Eardrum killer. Yes. Speaker destroyer. I can imagine that being the case. Right, and into this we want to bring in some of the very basic structure. We know we're going to need sort of all that kind of things later. Not right now. Bring in our sound PGEX. Now, the PGEXs all inherit from a base class called PGEX, which gives it some access to the Pixel Game Engine. Not necessarily access that's useful, but the Pixel Game Engine can also then tap into the derived class here and actually call functions at certain times. So you can have PGEXs which are responsive to things happening on startup and shut down and before the frame is run, before the user has a chance to do something in on-user update and on-user update. So there's lots of break-in methods to you can provide overrides for, which allows you to manipulate how the PGEX behaves. Right. So we've basically got our cut and paste error, cut and paste error. So going to be sound wave. See, I no longer like the all capitals as a way of doing things. It's my tastes have changed. And yeah, we need to include a Pixel Game Engine, of course, don't we? So the plan will be that we'll put in our basic interface up here, which was these functions. And now these functions I'm quite happy to sort of keep as they are, but we might change some of the types over a little bit. So let's just grab all of that, bring that into. Oh, hang on, I've just gone ping. Password required for additional security. That's annoying. Right. Don't worry, it is not the end of the world. Now, these are all static. There's a reason these are all static, and that just makes the thread handling very simple. But also, I don't expect you to have multiple audio devices active at any one time. Don't forget the end user here is not necessarily the pro audio programmer. Am I going to keep the sample rate as 41 kilohertz? Am I going to go with the cool kids as 48 kilohertz? Well, that's why I'm thinking of moving over to this waveform buffer, this continuous buffer, because then we can actually do on-the-fly sample rate conversions. Oh, hang on, I've got a from Kanawanagasaki Yoko. Kanawanagasaki Yoko. Hello. You're watching my videos. They're great. Oh, thank you very much, man. Cheers. Appreciate that. The live streams are nothing like the videos, I should point out. And we're almost done, I'm afraid. I told you we don't get very far in a code zone, do we? Basic changes that I don't like anymore. I don't tend to use the regular types like this. I tend to use now the standard int types instead. I just prefer them. I think they're far more visible. People go, why do you like Hungarian notation, Jerry? But then I'm more than happy to use a type like that. So, swings and roundabouts. So initialize audio, probably going to change. So we could get rid of initialize audio. We could have that sort of automatically called by the Pixel game engine, but then it doesn't give the user the choice to actually pick anything. I mostly rename those to, yeah. So you do them in a sort of a Hungarian notation style, right? Gotcha. So static bool, so these are fine. I'm happy that basically the sound wave is going to be a singleton, an easy to use singleton. So we'll do the same. Let's start filling in some of these things. We're not going to get very much further tonight, I'm afraid, but now blocks and block samples. These are a throwback to the very original noisemaker that was my first YouTube video. And it gave you the ability to play with the number of blocks in the loop that I was telling you about before, that the driver can look at, and how many samples are in a block. And that allows you to tune the latency to your hardware. Now, I'm interested in sort of real-time sound generation, synthesis, and as a musician, I also like to be able to play the stuff that I'm creating, which means I need the latency to be as low as possible. Certainly it's got to be, for me, it's got to be below sort of 10 to 12 milliseconds before I start being able to pick up on it. And if I should also mention, I'm quite keen on bringing into this version of the Soundwave PGEX audio input as well. So that way we've got the full loop, so you can use microphone sources, audio input sources, manipulate them and output them. That's going to be really what I'm trying to achieve here. I find writing uint x very jarring. I don't mind a good underscore in the language. Sorry, Dandestein, I'm being really slow there. If you're catching up with the chat. Right, so little changes like that is what we're going to make. So I know that I'm going to keep these two functions exactly the same, but I might rename them now. Or maybe not, I don't know. I don't like using the other ones for the floats. I don't know why there isn't sort of float 32 and float 64 sort of readily available. I think actually there might well be, but I don't tend to use those. But I know that this one's actually for the channels, so they can change. Right, play samples. We're never going to have negative samples, so that's fine too. Stop all, load audio sample. For now, I'm just going to... I can actually leave that as it is. We're not going to worry about resource packs today. So all of that, I'm happy with being sort of the same interface. I've never necessarily had a problem with the interface there. We'll need to write some comments. You know, like the inconsistency between float and double. Yeah, yeah. It should have been single. I'm sure it was at some version. You could just use single. Single a keyword still? No, it's not a keyword anymore. There used to be, or maybe it wasn't C++. Maybe it was Pascal or something. That's the easy way around it. Yeah. You don't think it ever was a keyword? I'm sure I saw it. Was it as a modifier somewhere? I say it could well have been Pascal. So that's the basic user interface. And so these will all need an implementation down below. But what do these go and do? Well, they're going to go then and invoke rather than providing the implementations of these individually, I think we'll create a class which is virtualized, that then they become the different driver interfaces. So something along the lines of audio driver, audio deriver. Audio driver becomes this is hidden from the end user in a way. There's no need for the actual programmer of the Pixel game engine to understand what's going on. And these will contain the implementations of these functions plus a few more, because what I noticed was there was a lot of repetition in between these implementations. So I think we can actually make the audio driver writer's life a little bit easier. But what those are going to be, I simply don't know at the moment. Load audio sample should probably return uint32. Right, okay. The reason it doesn't is because, firstly, it can fail. And so it's a bit of a nasty way of also returning there's an error has happened. The other reason, I have in my head was there two reasons? Yeah, I think I had two reasons, but it's gone now. Yeah, it can fail and return -1, which is tested for. Maybe that's a usability function that we should change. Oh, well, no. Right, standard in. I'm going to have to get the old ban hammer out soon. Oh, Magetsu, not you as well. The audio samples are only returned as a number to the end user. So it's -1 for fail, or then it's 0, 1, 2, 3, or 4, depending on the sample. And that's because the actual user of the Pixel game doesn't care how the samples are stored behind the scenes. They just want to be able to play them. Just throw an exception. Oh dear me. Oh. Now you see, this is the problem with all these modern C++ techniques. Firstly, I don't know them, but secondly, they don't appeal to me. They're just awful. If you ever actually look at some code that has to make use of standard optional, it's an absolute mess. There's nothing wrong with null pointer. I don't know what the problem is with null pointer. I'm more than happy. I understand it. I'm capable of working with it. It's fine. Controversial opinions here on the CodeZone. Well, sorry, Ronin825, not for much longer. In fact, not for very much longer at all, because that is the end of it today. I'm afraid we don't tend to go for more than an hour in a CodeZone. Now, if you are sort of new to the CodeZone stuff, you might be wondering what's going on. Why is it episode 44? You may also not be aware that I have a sister channel on the YouTubes. Just a second, I'm pulling it up now. Called JavidX9 Extra. It's not as popular as
and today we're going to be programming something.
And on that channel, there's every single code zone that we've ever done. They're all nicely color coordinated, plus all sorts of other things that are silly going behind the scenes. So everything that we stream goes up there. Now, most of the code zones are about building a space game. It's called Space Thing. But invariably we end up just looking at other bits of text. So there's quite a lot of content on there for people to chew through if they want. There we are. Thank you, Dragoneye. Car Crime City ones. Oh, thank you, Ronin. And Korzuken, hello. Yeah, Car Crime City. A lot of people sort of saying, "Oh, it'd be good if we could get Car Crime City up and running again." Maybe. I think I had my reasons for sort of just stopping that one. Anyway, one of the ultimate aims with the audio project I want to get some basic audio videos done. I want to get some audio effects done, but I do intend to sort of go back to the NES emulator. Now, I'm not going back to lots of videos on my channel. I've sort of had my reset. I've decided that what's been in the past will stay in the past. But one of the things I have decided to move forward with is finishing off the NES emulator's audio implementation, because I would like to find a way of sort of extracting the chip to use the chip as a standalone audio device, an audio simulation. Now, maybe this is where the community can help me. It would be useful if anybody is aware of a file format that contains the sort of sequences for these chips, in which case I can then create a player for these chips and we can visualize it playing. We can find lots of songs and tracks. I'm sure this is not an original idea at all, so I'm fairly certain these resources must exist. You know what's really going to annoy people now that do actually follow these things? Look at the shade of yellow here as it changes. Oh. In fact, all of the colours here are subtly different each time round. There you go. Yeah, that's what I'm saying, Anderson. I know these things, they do exist, but it was just I quite like the idea of just finishing off the 2A03 and getting it right, because there's one audio channel and PCM missing from the NES implementation. Now, I'm not interested that much in implementing the rest of the NES in order to do that. Right. Oh, by the way, yes, if you've not seen anything, if it says not CodeZone, it's currently hurdy-gurdy. So it's where we spent a lot of time building a hurdy-gurdy. Look at that one. That one was really long. It was 2.5 hours long building a hurdy-gurdy. Believe it, would you? Right. Thank you very much, guys. Take care of yourself. CodeZone will be back again around 8:30 next week, next Tuesday, if not before. I don't sort of announce them in advance, but Tuesdays tend to be the CodeZone night. And they used to be at 8 o'clock. They're now starting about 8:30, 9 o'clock, because I have to put the little one to bed. So thank you all for watching, and take care. Good night.